Hi everyone, welcome to this tutorial where we will learn how to build enterprise-scale generative AI agents using Amazon Bedrock. What exactly are enterprise-scaled AI agents? Well, enterprise scale means that we want to build an AI chatbot that is production-ready, meaning that you can access it from all over the world, and hence that it's not only available on your local laptop. Secondly, we want our application to be scalable, meaning that whether one person accesses your app or 1,000 people, that it will still have the same performance and efficiency. And thirdly, and most importantly, I think, we want our data to be secure, because companies and enterprises, they often have this internal knowledge that is very enterprise specific and sensitive and cannot be shared with the general public. So we want this data to be only available to the right persons that have also access to the AI chatbot. And more importantly, we don't want to share our data with, for example, ChatGPT to retrain other algorithms out there. AWS offers this wide variety of services that accommodate an enterprise scale AI chatbot. First of all, we can store our data in S3. Secondly, we can make our application available using API Gateway and Lambda. Moreover, recently they have developed a new service called Amazon Bedrock, which allows you to easily integrate these large foundation models such as Anthropic's Claude model and integrate it into your Lambda functions or whatever functionality you want out there. So before I walk you through the infrastructure that we will build during this tutorial, I first want to introduce the RAG-based approach that we will use for our AI chatbot. If you have never heard of RAG, it stands for Retrieval Augmented Generation. And this approach is generally used when you have a very large database of large documents, meaning that your database is too big to have as an input in a large language model. So the way it works is that the RAG-based approach splits your large database into small chunks. All these chunks then get embedded into a vector database, and then based on the semantic similarity of the user question and the chunks of data in the vector database, the right information will be retrieved from the vector database and used again as an input for the next large language model. This might sound a bit complicated, but I've written another article on this, which you can check out in the link that will be provided in the resources of this video. So now I will give you an overview of the infrastructure that we will walk through in the rest of the tutorial. So there are 5 AWS services that we will use for this application. First of all, there is API Gateway, which allows the interaction between our front-end interface and the Lambda function, or Lambda function, which is then integrated with Amazon Bedrock. Amazon Bedrock is used to build our AI chatbot using the vector base that is stored in AWS's Open Search service. And our data in this vector database will be stored in an S3 bucket. And all this will be tied together using the serverless framework. So in order for you to follow along this tutorial, I think it is required to have some basic understanding of the AWS services at least. Also, some basic Python knowledge comes in handy, I think. And then finally, we will also use serverless. If you're not familiar with that, I don't think it will be a big problem because I will walk you through the setup of serverless and provide you a template of the infrastructure code. So yeah, I hope you're as excited as I am, and let's dive into the code base. So the first thing that we want to do is building our knowledge database. Our knowledge database will contain all the information that we want our AI chatbot to have access to. And this knowledge database is composed out of 2 AWS services. First of all, we have the S3 bucket, where we will store the files that are actually comprised in the dataset. And then secondly, using Amazon Bedrock, we will implement a knowledge database that is using the files stored in the S3 bucket. So when you are on your AWS console, you can redirect to the Amazon S3 bucket and create a new bucket. We will call this bucket tutorial AWS Bedrock, and you can leave all the default settings as is. Okay, let's go ahead and create bucket. Now you can go inside the bucket and we will create 2 new folders. The first folder being dataset. And here we will store all the documents needed for our knowledge database. And then secondly, we will create a folder called Lambda layer. And in this Lambda layer, we will later store a zip file containing all software packages required to run our Lambda function. Okay, so as you can see, we have now an S3 bucket that includes 2 folders being dataset and Lambda layer. So now let's direct inside the datasets folder, and now we will upload the files that make up our knowledge database. So for that, I will go to Add Files, and I have a PDF that I retrieved from Wikipedia containing information about large language models. But here you can integrate as many files as you want actually, because our knowledge base can be as big as we want because of the RAG approach that we will implement, of course. So if you have selected your PDF files or Word documents or whatever kind of textual data, you can go ahead and upload it. Okay, and once uploaded, we can close the S3 section and go to Amazon Bedrock. Thing that I want to point out here is that Amazon Bedrock is a relatively new service that AWS is offering, so not all functionalities are available in all regions. So for this functionality, it might be best for you to switch to US East 1. If you watch this tutorial at a later time point, it might be available in another region as well already. So if you go to the menu on the left side, we now want to go to knowledge bases, because here we want to create a new knowledge base that contains the information that we just uploaded in S3. So if you scroll down, you have here the Create Knowledge Base button where you can click on, and we will call this knowledge base tutorial AWS Bedrock. You can add a description here if you want so. Then next there needs to be an IAM permission set to this knowledge base. We will just leave the default settings to create and use a new service role. You can also add text, but also this we will leave open. And if you go to the next settings step, we will set up the data source and the data source name. Again, we will rename our database to tutorial AWS Bedrock. And here we can finally select the S3 bucket that we have created to upload our data. So what we will do is we will browse through our buckets, and here you can see the tutorial AWS Bedrock bucket. We will click on this, but very important here is that you also need to point to the folder where this dataset lives. As you remember, we have created two folders, the dataset folder and the Lambda layer. So we want our knowledge base only to access the datasets folder. So for that, we will just add the path to that folder. Okay. Next, we need to select the model that we will use to create our embedding. So as I already mentioned before, we have our textual database that will be converted into vectors, and this process is called embedding. And for that, you need to select an embeddings model, which we will just use Amazon's Titan embedding G1. But as you can see, there are other embedding models out there as well. Okay. Then we will create a vector database. There are different vector stores or vector database offerings out there. You have Pinecone, you have Weaviate, but Amazon also offers their own vector store, which is called Amazon OpenSearch Serverless. And in this tutorial, we will use Amazon's OpenSearch Serverless vector. Again, here we will leave the default settings as is. And finally, we are at the review and create page where you can have a look at the settings of your knowledge base, and if everything seems right, you can go ahead and create the knowledge base. This will generally take a couple of minutes, so bear with me. After a couple of minutes, our knowledge base is ready, and you can see all the information regarding the knowledge base in here. Two important things. First of all is the knowledge base ID. This ID we will need later on when we are developing our serverless file. And secondly, the data source. We did already link our S3 bucket to our knowledge base, but it is also important to sync them. So you need to click here on syncing data source to make sure that all the data included in your S3 bucket is also loaded into the knowledge base. And once this is done, we can continue with our setup. Of note, every time you upload or change a document in your S3 bucket, you need to resync the knowledge base. Okay, once we have created our knowledge base, we can now go ahead and integrate everything in a serverless template and also build our Lambda functions and our API gateway and of course our AI chatbot itself using Amazon Bedrock. So the first thing that we will do is initiate a new serverless project. If you're not familiar with serverless, serverless allows you to deploy these AWS services in a way that you can replicate it easily. And this type of framework is typically called infrastructure as a code. And it's very convenient to keep track of which services you are using and which services are interconnected. So to initiate a new serverless project, you of course first need to install serverless. In my article, I provide a link to the installation guidelines of serverless. And once you have installed serverless, you can initiate a new serverless project by running SLS, which is an abbreviation for serverless. Next, you can select a template that you want your serverless project to start from, and in our case we will use the template AWS Python and HTTP API because we want to create an API. Next, we can give our project a name, and again we will use tutorial AWS Bedrock. Now it is downloading the template. We don't want to register our login, and we also don't want to deploy now because we first want to make some changes to our setup. Okay, and if you now look into your folder, there will have been created a serverless project in which we have a serverless YAML file, and in this YAML file we will provide all the information regarding the services that we need. For now, you can see that there is one basic functionality in there, which is a Lambda function called handler hello, which is linked to an API. However, the setup that we have is a bit more complicated as we are also integrating AWS Bedrock. So first of all, let me copy the template that I have provided and is also available on GitLab and in the article that I wrote. Okay, as you can see, this template is already a bit more complicated, but I will walk you through it step by step. So the first line is the name of your service, which we will call knowledge base API because it's an API that will access our knowledge base. And then in the provider section, we want to use AWS because you can use serverless also with other cloud-based services. The runtime will be Python 3.12. The stage is development for now. In the later phase, you can also use a production stage here. Our region is US East 1. This is very important because, as I mentioned before, the knowledge base and other functionalities are not available in all regions at the moment. So having the US East 1 region here is quite important. And then we will set up some environment variables. First of all, there is the knowledge base ID, which is the ID that is provided by AWS here. So this is an important ID to save. And as you can see, it loads the variable from our custom section here, where you can paste your knowledge base ID like this. And finally, you need to define a role to give Bedrock access to certain functionalities. Then we have the custom section, and as I already mentioned, we add here our knowledge base ID. And here as well, we need to specify the S3 bucket used to store our Lambda layer, which was tutorial AWS Bedrock. Then the next section defines our Lambda functions. I will go into depth into the Lambda function itself, but for now we define the handler here, the location of the handler. We also give it a memory size and a timeout of 60 seconds. Then you need to provide it a layer which includes the software packages to run the Lambda function, and these are defined here later in resources. And then we have the events, which specifies that the Lambda function will be integrated in and get API requests. And the resource section defines the Lambda layer. And you can basically copy paste this code. What it does, it points to the right Lambda layer. So the only thing that you need to make sure of is that the name of your S3 bucket is correct, which is defined here, Lambda layer S3 bucket, as well as the path and the name of the zip file which contains the Lambda layer. This Lambda layer, you can find it on my GitHub page, so you can just copy paste it, upload it as well in the S3 bucket in the Lambda layer folder, and then provide access via this resource section. If this is the first time that you ever use serverless and the first time that you see such a serverless YAML file, this might look overwhelming. Take some time to go through the code, but the main takeaway here is that in this file you specify all the services that you need and you also link them together. So we provided the knowledge base ID, the location of the Lambda layer, but we also provided permissions for different services such as Bedrock. So what you could also do is setting up all these functionalities via the AWS console. Of course, this way is a bit more easy to replicate. And what is also very convenient is that if you want to shut down your application, you can easily delete all the AWS service stack by deleting the serverless application via command line. So you don't need to go through all the services manually in the AWS console, but you can just do it via command line here. So I think it's a very convenient skill to learn. Okay, I think we can now continue with our Lambda functionality, which was defined here in the function section of our serverless template. And as you can see, the name of the Python script which contains our Lambda handler is called handler.py, which is here. So once we open handler.py, we get our complete Lambda function. And here then is the Lambda underscore handler functionality that is referred to in the serverless template. So this Python script contains two functions. One I already mentioned, which is a Lambda handler function that is accessed in the serverless template. And then second, we have the retrieve and generate function. And this is really the main functionality of our AI chatbot, because this is where we will have the interaction with our large language model. So before I dive into this code, I want to give you a general idea of what the Lambda function does. So our function takes two inputs. First of all, we have the question that is asked to our large language model. So for example, my documentation is about large language models, so I can ask the question, how are large language models built? And then the second input of our function is a session ID. And this session ID is required to allow our chatbot to store previous questions and answers of our conversation. This is a key parameter of a good AI chatbot, I think, which is when you ask multiple questions that our chatbot still has knowledge of the previous questions and answers, so that the chatbot is aware of the conversations that has happened before and can also have access to this knowledge to reproduce a more fluent answer to your question. So first, let me walk you through the retrieve and generate function. This retrieve and generate function accesses the Bedrock agent. As you know, we will use AWS Bedrock to build our AI chatbots with the RAG-based approach. And when you're using Python as coding language, you can access this Bedrock agent using Boto3. So the first two lines in this Python script are setting up a Boto3 session. And then we will initiate the Bedrock agent using this function, this boto3.client functionality. Again, important here is the region name that we give. As mentioned before, it is important to use the US East 1 region. So this Bedrock agent has a function which is called retrieve and generate, and this is the function that will then access a foundation model or a large language model and interact with our user's question. So the retrieve and generate function has as input the question that is asked, and then also some configurations. And these configurations on the one hand contain the knowledge base that we provided, as well as the model that we want to use for our chatbot. And then finally, if available, also a session ID is provided. So the first line of the code actually checks if the session ID is available. If that is the case, it will be given to the retrieve and generate function. And this is done so that the retrieve and generate function can find back the previous questions and answers based on this session ID. The last part of the function is exactly the same retrieve and generate functionality, but without the session ID. And that brings us to our last function, our actual Lambda handler. This is the function that is triggered when an API request is provided. So the Lambda handler takes as input an event, the event which also contains the query string parameters that are provided in the API request. And generally we will use two query string parameters. First of all, of course, the question, and secondly, the session ID. So the question and the session ID are extracted from the URL of our API request. Then we have the ID of our knowledge database, and if you remember, this was provided as an environment variable in our serverless template. Also, we need to provide the model that we want to use, and in this example we will use the Anthropic Claude v2 model. Before I continue with the rest of the code in this function, I want to explain one configuration that you need to set up via the AWS console. If we go back to our AWS console, we are here on the Amazon Bedrock page, and if you scroll down in the left side menu, you will have here at the bottom model access. And here you can see all the base models that you have access to. However, in order to be able to use the models, you need to request access. So this you will need to do for the instance that you want to use. We will use the Anthropic's Cloud model. So what you can do is requesting the access. I already requested access for most of the Anthropic models. However, if you haven't already, you can go to the up right Manage Model Access button. And there you can select the models that you want to request access to, which you can do then by saving the changes. And after a couple of minutes, the access to the model will be provided to you. So make sure that you request access to the model that you want to use in your chatbot. Okay, that brings us back to our code. So I have access for the Anthropic Cloud v2 model. I again specify my region, and then we generate the model ARN, which is a combination of the region and the model ID. And then we will use the retrieve and generate function that we have created before, where we have 4 input parameters. We have our question, our knowledge base ID, our model ARN, and our session ID if provided. This will return a response, and this response contains both a output text, so a reply to our question, and also a session ID, which we can extract using this code. And then finally we will create our response, so our API response, which generally contains headers, a status code, and a body. The status code is 200, which means that the API request was successful, then some headers and a body, and in this body we will combine our question, our answer, and our session ID. So as we now have defined both our serverless template as well as our handler used in our Lambda function, we can go ahead and deploy this serverless project. So we will do this by opening up a terminal. So in our serverless project, we will run the command sls deploy, which will deploy our serverless project. Before you do this, make sure that your AWS configuration, so your access key and your secret key, are set up accordingly. And then this will take a couple of minutes, so be right back. And after deploying our serverless project, we get back our API or URL, which we can copy and test in Postman. So here we paste our URL, and then here in the query parameters we can give our question, and in value we can write down our actual question. So since my document was about large language models, I will ask the question, what are LLMs? And then we can send this API request, and after a couple of seconds we get the reply back. LLM stands for large language models. They are AI systems trained on large amounts of text data to generate human-like text. And as you can see in our response, we also get a session ID. So this session ID we can also copy and give as a query parameter in the API request. So we give our parameter session underscore ID, and we paste here the ID. And when providing this session ID, the Lambda function will use the previous question and answer that we already communicated with our LLM. And now we can ask a follow-up question. For example, we can ask who introduced them first. And as you can see, we here need the context of the previous question in order for our model to understand the question, because otherwise the them here wouldn't really make sense. And indeed we can see that using the session ID, the history of our chat conversation was used to answer this model, and the AI agent knows that we're talking about LLMs. Okay, so this brings me to the end of this tutorial. I hope with this information you can go ahead and create your own AI chatbot. If you liked the tutorial, please give me a thumbs up. I will provide all the resources in the description of this video. Feel free to check out the article that I wrote and also my Instagram page or LinkedIn page. Thank you for watching.